Okay, now I think I might have already told you how to do this. I might not have. I don't know. Okay, so you have an exponent, but it's a fraction. Here's what that actually means. Circle the base, 125, and then just the denominator portion. What that means is the cubed root of 125. That's what that means, okay? So just go to your sheet, look at your cubed roots. 125's here, okay? It's 5. So I can do away with that, and it's 5, but it's 5 to the second, which means it's 5 times 5, which is going to be 25. Remember, it's not 5 times 2, it's 5 times 5, 2 5s. Okay, now you got 27 and 2/3 times 27 and 2/3. So first off, circle each one of those, and I guess you only need to do it once because they're exactly the same, okay? So you have 27 to it's the cubed root of 27, okay, essentially. That's what that means. So look at your cubed root. 27's here, it's 3. So both of these go to 3. But we got to now bring that top power. They're both still to the second. So 3 times 3, that's what 3 to the second means, is 9. 3 times 3 is 9, and that's going to be 81, okay? Now, if you have a negative power, if the exponent's negative, you can fix that very easily by putting a 1 over it and then make it positive. Now remember, whatever I come up with, there's a 1 on top of it. And then I go about it the same way. Okay, so you got a 4th root, and it'd be 81. So I go look at my 4th roots, and I see 3. Remember, there's a 1 on top of it, so this now goes to 3 to the 3rd power. Now I evaluate 3 to the 3rd power. 3 times 3 times 3 is 27. So that would be 1 over 27. Try to remember to put the 1 over it. Same idea here, negative power, you can make it positive if you put a 1, then you don't have to worry about the negative. That's how negative power works. It's called reciprocating it. Okay, so I look at this, and I make a cubed root, and I put 343, okay? So 343 is 7, okay? So it's 1 over 7 to the second. Remember, the second drops down because you got to remember the 2 there. And then 7 times itself, that's 49. Okay, so it's 1/49. Okay. Okay, next one. Not a negative, so I don't need the 1. So remember what that really means. It means the square root of 9. Square root's this. 9's here. It's 3. So I just cross it out, put 3. But it's 3 to the 5th, okay? So I go 3 times 3 times 3 times 3 times 3. I got 243. Okay, there's a negative exponent. Put a 1 over it. So again, we can get rid of that first dumb-looking fraction if I can make a square root of 81. And that's on this sheet, and 81's here, it's 9. So this goes to 9, but it's 9 to the power of 3. So I take 9 times 9 times 9, 729, but remember it's 1 over 729. Okay, so be careful with that. Remember the 1's there. Okay, it's positive, so circle that. 625. 4th root of 625 is 5, okay? So it's 5 to the 3rd. You don't need the 1 over it because it wasn't negative. 125. Okay, pause the video right now, okay? That star problem I'm going to come back to. Do 1 through 7 and then stop, okay? It's pretty cookie cutter, you know, well, except the negatives, you got to fix those with the 1 over it, but should be okay, but stop at 7 and then just forward the video and then just resume the video because that problem is a little variation to it. All right, so let's look at these, okay? circle that and circle that. We don't have the benefit of having the same number, so I got square root of 7 and square root of 21. Here's the problem with that, though. Seven's not here, and neither's 21. So I got to go to plan B this time. Now you're going to make square roots just like you did over here. You're just going to write the square root of 7. Now it'd be 7 to the first, but that's just 7. If I have a power of 1, I really don't need it, okay? Because 7 to the first would be 7. Now you're going to do these like you did on the previous assignments. You're going to multiply what's inside the radical. 7 times 21. It's 147. Now 147 isn't here either, okay? But then you were going to divide and try to rewrite it into radicals. And one of them should work. So 147 divided by 144, nope. 147 by 121, nope. 100, nope. 81, nope. 64, nope. Cha-ching, so 49 and 3. So that then turns into 7, and I end up with 7 radical 3. Okay, so that's what you have to do when the radicals don't just work out, okay? You turn them into square roots and then like a problem. Now look back at that, and number 8, try that one, okay? These are cubed roots, so that's a different list, okay? So that's the cubed root of 5 times the cubed root of 25. You do it the same, you're just using different numbers. Let me know if you need help on that one.